A 50-pound ice sculpture is melting at a rate in which 80% of its weight remains each hour. Draw a graph to represent how many pounds of the sculpture is left each hour. So what we want to do here is we want to write a geometric equation, and then we're going to graph it. So remember, to write an equation, we only need two pieces of information. The general form of the equation looks like this. And the only two things that we need are A1 and R. A1 is the starting value, or the first term in the sequence, and R is the rate that we're multiplying by every time. And this problem gives us both of those. It says it starts off at 50 pounds. That's going to be our A1, the starting value. And then it tells us the melt rate, which is 80%. So that's going to be R. R is 80%. Now, of course, we can't put 80% into a calculator or into an equation, so we're going to write that as a decimal, 0.8 or 0.80, whichever one you like. And so that's it. That's going to be our equation. So A sub n equals 50 times, and then our rate of 0.8 to the n minus 1 power. Now, there's several ways you can do this. If I was going to write a sequence, for example, I could probably get the first few terms in the sequence by myself. Oh, gosh, my dog is contributing. Stella, you want to be a part of this video? I know the first term's 50, and I know 40% of 50. Oh, sorry about the delay there. My dog was barking at a door-to-door salesman who was not interested in participating in this video. Anyway, as I was saying, I could probably do the first couple of these by myself. I know it starts at 50, and I know 80% of 50 is 40. And I think that 80% of 40 is 32, and that's kind of when I run out of gas. So I'm going to go to the calculator for this, and I'm going to put this equation into the calculator. I can't put n's, obviously, or a n. I'm going to use x and y, but otherwise it's going to look pretty much the same. So I'm going to go to y equals, and I'm going to put in 50 times, and then it was 0.80, and then I'm raise it to the, instead of n minus 1, the x minus 1 power. And so if I go look at my table, I'll do second graph and go look at the table. You can see I got 150, 242, 332, and then this is where the numbers get kind of ugly. 4, 25.6, 5, 20.48. But this is like each hour, this is how much of the ice is left. So I start off with 50, and then after 2 hours, it's down to 40, and after 3 hours, it's down to 32, and so on. But if I wanted to see a graph of what this looks like, it'd be really easy for me to do that. All I have to do is just press the graph button. I'm going to go ahead and press graph, and I just see this tiny, tiny little piece of the graph up here. And that's because my window is going from -10 to +10, which is not going to show me 50 pounds of ice over multiple hours. So I'm going to press the window button, and I'm going to have my x go from 0 to 10 is fine. 10 hours, it seems like it's good enough. And I'm going to have my y go from 0 to 50 is where it starts. So let's say maybe 60. And then we'll go ahead and graph it. And that's a pretty good graph of what this ice melt is going to look like. And so this is maybe the easiest way to get a graph, is to write the geometric equation and then just put the equation into the graphing calculator, use the table, which we get by doing second graph, to get a few coordinates. And then once you get a few coordinates, just connect the coordinates with a smooth line there to get the shape. And that's the easiest way to graph a geometric sequence, is using the graphing calculator after you write the equation. A 50-pound ice sculpture is melting at a rate in which 80% of its weight remains each hour. Draw a graph to represent how many pounds of the sculpture is left at each hour. So we could draw a whole bunch of coordinates for this, but let's just do 5 or 6 maybe. So we know it starts off at 50 pounds because the problem says so. It starts off at 50 pounds. So I'm going to say that x is going to be hours because it says 80% each hour. And we'll say y is pounds of the sculpture. So at 0 hours, the thing weighs 50 pounds. And then 80% of it remains after 1 hour. So if I do 50 times 80%, I get 40. So after 1 hour, 40 pounds are left. And then 80% of 40 is 32. 4 times 8, 32. So then after 2 hours, I got 32 pounds left. And that is when I lose the ability to do this without a calculator. 32 times 0.8 is going to be a decimal of some kind. So let's go to our calculator and do 32 times 0.8, which is 25.6. So after 3 hours, we've got 25.6 pounds left. So 25.6 times 0.8 is going to give us our fourth point. Let's just go ahead and do 5 points. So we'll do 4 hours and 5 hours. So 25.6 times 0.8 is going to give us 20.48. So after 4 hours, we've got 20.48. And let's do one more. 20.48 times 80%. This will be our last point. 0.8 is 16.384. That feels good enough for a graph. So after 5 hours, 16.384. Literally, we could go forever because thanks to Zeno's paradox, which you'll learn about in calculus, this sculpture will never completely melt. If we keep going 80% and 80% and 80%, there will always be some ice left. So this could have an infinite number of points. Based on this model, this is the never completely melting ice sculpture. And if you're thinking, that does not make sense, you are right, it does not. When you get into, I said calculus, I guess I should say pre-cal. In pre-cal, when you learn about the limit, then you will understand Zeno's paradox and why it actually is possible for the ice sculpture to completely melt. Okay, so let's go ahead and put our points on here. We've got 0, 50, that goes about right there. Then 140, 232, 3 and 25.6, 4 and 20.48, and 5 and 16.384. And that's a pretty decent graph, I think, right there. Comparing pounds and hours, and you can see it does look like an exponential decay function because this is melting, the amount of ice is decaying. And so we could have done this on the calculator, the graphing calculator, and use the table, but this works just as well to do it this way, just multiply by 0.8 every time. And so this is how you graph a geometric function.